Good afternoon, everyone. And in the last session, yesterday class, we were talking about input formats of MapReduce. And today we will be talking about the output formats in MapReduce. So before getting into output formats, let us see what are the things that we will be discussing in output formats. See, in output format, whatever the format let it be, like for input, we have taken different criteria. Like one is the input can be a database file, or the input can be multiple files from different data sources, or the input can be a file, or the input can be a line of text. So whatever the input let it be, the output will be always in something like will be reduced step. So the output you are going to get a single value, the reduced value. That is one thing that you should remember when you talk about output formats in MapReduce. And see, like you can see a diagram, and in this, if you look into this diagram, you can see it flows from right to left, not from left to right. Okay. So start with this last called multiple sequence file output format. So we have multiple output formats. That multiple output format can be text or can be a sequence file. At last, if you see when all it is getting like in a class hierarchy, like level 1, level 2, level 3. At last, you can see a single root element, that is a single reduced value. So where you can see a single reduced value. So the output can be a sequence file. I mean, the output can be taken from a sequence file, or from a text file, or from a sequence file. And to specify if there is no output, like when it is returning an empty, and to specify that no output is there, we can use a null output format. And this is also called as like a lazy output format that we shall discuss later. Okay, lazy output format, and database output format, filter output format. And regarding filter, we have discussed yesterday. So what is the meaning of filter? Why do we need a filter in MapReduce? And what is the role of filtering in MapReduce? And at last, if you look into this, you can see output format k comma v, where it is again going to be key and value. Okay, so it is the output format class hierarchy in Hadoop MapReduce. Okay, so this is just an hierarchy where you can see like how the flow goes from, like if you take input, so this will be done in the mapper phase. Whatever the input formats that which we have discussed earlier, those talks about mapper phase. All the things get happens in mapper phase. And the things which we are discussing now, which we'll be discussing today, that will be a part of reducer phase. Okay. So by a default, I mean, okay. So the default output format in Hadoop MapReduce is text. Okay. So irrespective of anything, the text output format will be the default format, which writes the set of statements or records as a line of text in the output screen. And you need not to you need not to worry about the type of data which it is processing. Is it processing integer or float or character or string? But one thing is like if you take Python, so Python is well supported to use. Python and Java are most supported languages to implement these kind of MapReduce things. So where even Python, where each and everything can be treated or can be called as objects. By default, the things in the objects in Python will be taken as string objects. Okay, so if you want anything to be to be specified as integer or character or float, then we need to add the return type. But by default, that will be treated as strings. And here, to know which object that you are calling, we can make use of a method called toString method. Okay, so which where each key and value is separated by a tab character, and you can even have the key comma value, or it can be written as key arrow mark value, or it can be written as key space value. It can be of any format. Okay, so in this way we can represent, or we can access, or we can get the text as in the output of a Hadoop MapReduce program. So even if you take a program to find the frequency of word counts, as a result, you will be getting the key and the value. That is, number of times it is being repeated in the given file. So at last, it will be resulting in a key value pair. And next is about binary output. In input formats, we have a lot of subtopics, we have a lot of subsections. But output formats, we have only three to four. First is text format, second binary output format, and third multiple output format. And thereby we will be talking about one more thing called lazy output format and database output format. So this is all the different output formats that is being supported with MapReduce. Okay, so if I take binary output, so thereby I will be getting as binary values as my result, like zeros and ones, or true or false, or like boolean conditions, true or false. And here it is of three categories. One is sequence file IO, sequence file output format, and second sequence file as binary, and third is map file output format. And if you take first one, sequence file output format, what it does is, so as in the map reduce phase, you can see combiner, and then you can see reducer, right? So whatever the output of the combiner phase will be passed towards the reducer as input. That will further get you the output. Okay, so from mapper phase to split phase. So thereby this output will be acting as input to the next phase. Similarly, when I talk about a combiner, so the output of combiner phase will be acting as input to reducer, and the output of intermediate phase will be acting as input to combiner phase. And this sequence output file format is good when we use this kind of when we apply this in combiner task, where it is, where you want to get the input to be in a compressed form. So thereby you can assure that your system speed also gets improved. And next thing is that you are not going to waste huge memory space. You are going to use only lesser amount of memory space. And that is the first one, sequence file output format. And second, sequence file as binary output format, and it is a part of sequence file format. But what it does is, it writes the keys and values in binary format into the output screen, and that is the only difference when comparing to the last one. And third one is map file output format, and this writes directly the map file as output. Okay, further you may not even go for reduces. If you want anything to be in a certain sorted order, you can do with it reduces. And also you can ignore even like a key or the other thing. And the next part is multiple outputs. and the next one is multiple outputs. As we have seen the file output format class hierarchy, so where we have started with multiple output formats, and thereby it will be get combined to the next level. At last you will be getting key value pair. And here if you talk about multiple output formats, it is something like partition. So where for each and every combiner you will be getting a reducer, right? So if I take start from map face in input format, for the given input problem that will be get splitted, it will be get partitioned. For example, let me take that same example. If I ask you to count the frequency of words in a textbook, and you will be dividing this, I mean, you will be assigning this first 10 pages to candidate 1 and candidate 2. That is called partition. And once the map face is not going to be applied in common. So map face will be done for partition 1, and next map face will be done for, I mean, this will be happen parallelly. A separate map face will be done for partition 2. At last, when it is getting combined, so thereby your partition will be get again combined into a reducer. So thereby you can see for each combiner you can expect a reducer. And let me take an example. Like we have taken one example in module 1, like finding the maximum temperature recorded in a year. And let us consider the same problem in a slight different manner. Okay, so let us take the problem of partitioning the weather data set by weather station. So what we want to do is, and treat that like we're going to run a job, and what is that expected is output should be a file per station where each file contain all the records of that station. Is it clear? So we are going to do partition the weather data set. We assume that we have a weather data set from a weather station. Okay, and what is that we want to do is we need to generate a file for each station, and thereby each file should contain all the records of that station. Okay, that is the problem. Okay, so we have a weather data set of Bangalore, and let me take this example. We have a weather data set of Bangalore. From the given weather data set, you need to take off. You need to generate a file for each and every place in Bangalore. Okay. For example, like Majestic and the Australia, something like that. For each and every place, you need to generate a file, and thereby each file should contain the complete record of that particular station. So it is the problem. And to do this, what is that I want to do is, first thing, if I want to apply this problem, I should be knowing how many number of partitions that is required. I mean, if you want to get the number of data sets based on the locations in Bangalore, I should know how many number of parts, I mean, how many number of stations are there in Bangalore. Without that, I can't solve this problem. I mean, it is going to be fixed number. It is not a dynamic. It is static. It is going to be a fixed number. For example, like it will be around 45. So that 45 is a fixed number. So whereby I'm not going to increase it or not going to decrease it. It is a fixed number. So the one drawback is, when to apply this and to solve this problem, I should be knowing how many number of partitions that I require before solving the problem. That I should be knowing. That is the first drawback. Is it clear? Okay. So for a given data set, it is given a data set, a weather data set of Bangalore, where you want to get each file for each and every place, which should have the complete record of that particular place. And if I want to do this, if I want to solve this problem, I need to know how many number of locations are there in Bangalore. Without that, I can't do this, right? I mean, that is number of partitions. How many number of partitions that I'm going to do with a given data set, that I should be knowing. Without that, I can't solve this, which I can't assign dynamically, or which I can't upgrade dynamically. It is static. It is fixed one. So thereby number of partitions, number of blocks is going to remain same throughout my problem. It is not going to increase, or it is not going to decrease. So it is the first drawback. with this problem. And second thing is, once if I know this, how many number of partitions are there, then how many number of blocks, I mean how many number of records that is going to contain, or how many number of sub partitions it is going to hold. That also should be known to me. Without that, I can't go and implement it. I can't solve it. I mean, I can't apply this problem in a real time where things are getting dynamically updated. As this problem is to be get solved, we need to know about each and everything before partitioning the data. What is that I want to convey is, dynamically we are not going to partition the given set of data, given data set. We are not going for a dynamic partition. But when we talk about MapReduce, Hadoop, or when we talk about MapReduce, Hadoop, and all these are used for dynamic processing of our data sets, right? But whereas in this case, we are not doing that. So even this can be example for this multiple output formats, but these are the drawbacks with this approach. Okay, and the next part is the next part is, see, in this you can see something like partition number part R 00 and 001. I mean, for each and every partition, I can assign like numbers 0, 1, similarly next and next. That is the meaning of it. Just give me a minute. That's not moving to next slide. Okay, so that is where the multiple formats works. And if you are solve this problem, I mean, what you need to know, what is the station identifier names. You want the station ID to partition it, where each and every station will be given a unique ID. That is what that is given, like part 000, next 001. I mean part 0, part 1, part 2, part 3. Similarly, we can partition these things. And the next part is lazy output. See, uh, this lazy output works when you want the application that should not return, I mean that should not create any empty files. We should not have any empty files in the output as a result. In those places, we can make use of this lazy output format. Okay, so like you can see, some applications prefer that empty files are not be created. There you can make use of this lazy output, and which ensures that whatever the partition that which we are doing there, it is going to hold some data, where in each and every partition some data is there. So when it is getting into reducer, further your result will not be getting into reduced with an empty field or with an empty field value. So there, where that is the place where you can apply this lazy output format. And in Hadoop we have two things. One is called streaming, second one is called pipes. So these two supports lazy output format. And the last one is DB, database output format. And database output format, we will be talking in depth in module 5, and we will be talking with respect to a tool called HBase. And still now whatever the database tool that we have discussed are, one is NoSQL, and NoSQL is a column-oriented non-relational database, whereas SQL is a row-oriented relational database. And that is one thing that we have discussed so far, NoSQL. And if you can see here it is given HBase. And HBase means it is called Hadoop base. That is the meaning of this. HBase stands for Hadoop base. So it is again a part, a tool of Hadoop ecosystem, that is called Apache Hadoop base. That is the full name. That is the full acronym for HBase. Okay, and in this HBase, we have certain queries. Like if you take SQL, where you have a query like create star, create table, table name, and if you want to display the values, you will be doing select star from values. Similarly, in HBase, we have certain queries and which helps you in creating a database and in accessing that database field values. And one thing is, so what is the speciality with HBase? Why we need HBase? And the most important purpose of Hadoop is which performs well with the unstructured text, right? Which performs well with unstructured text. And this HBase works well with unstructured data set. And one more thing, this HBase is again a non-column orient. I mean, HBase again a non-relational data set. It is a column-oriented database like NoSQL. Okay, it is again and again like a NoSQL database, which is non-relational database which runs on top of HDFS, Hadoop Distributed File System. Okay, and we have discussed one more thing called Hive, HIVA, Apache Hive, and it is also again a database which works better and best for semi-structured database. Okay, SQL works much better for structured database, and Hive works much better for a semi-structured database. And this Apache HBase works well for unstructured database. Okay, so that is where we use Hadoop and Hadoop as HBase. It is called Hadoop base. So which process the database queries on top of Hadoop distributed file system. That is the use purpose of HBase. Okay, and we'll be discussing in depth about the query that we use to create a table in HBase and the query that we use to update or delete things in HBase. That we'll be discussing in module 5. Okay, so this is about output formats of MapReduce. So in output formats, the first output format is sequence. Sequence file output format. And sorry, first one is text, right? First one is text format, and second one is sequence file output format, and third multiple output formats, and fourth lazy output format, and fifth database output format. So altogether it is 5 output formats of MapReduce output formats. Okay, so this is